You ever stop and think about the invisible army of people and processes that keep your favorite apps from, completely blowing up every 5 minutes? Well, today we are pulling back that curtain. We're going to take a look inside the software testing lifecycle and meet those unseen architects of your digital world.
I mean, really, think about it. You tap, you swipe, you click, thousands upon thousands of times a day. So how is it that everything, mostly, just works? Well, I can tell you, it is not magic. It's a highly structured, super rigorous process that's designed to find and squash problems long before they ever get to you.
Okay, so let's get into it. To really understand testing, first we gotta see where it fits on the bigger map. See, building software isn't just chaos and code. It's a journey with a pretty clear path, what we call a life cycle. And turns out there are actually two of them we need to know about.
So on one side, you've got the SDLC, the Software Development Lifecycle. This is the whole shebang, right? From that first little spark of an idea all the way through coding, launching the app, and then keeping it running. But then, on the other side, you have the STLC, the Software Testing Lifecycle. Think of this as a specialized mission that happens inside that bigger SDLC. Its one and only job is to hunt down issues and make sure the quality is there.
So the main thing to lock in here is that the SDLC isn't just some random chaotic clicking around. No way. It's a formal, methodical sequence of activities. It's a process within a process, all designed for one thing: quality.
All right, let's look at the first part of this journey. Because before a single test is ever run, before anyone clicks a single button, a huge amount of planning and design work has to happen. This is the blueprint phase. This is where the strategy for the entire bug hunt is carefully drawn up.
And here it is. This is the entire roadmap for our testing journey. See how it starts with understanding the requirements? Then it moves methodically through planning, design, setup, and then, finally, we get to the action, execution, and closure. So let's walk through this step by step.
Now, out of all those steps we just saw, you could argue that test planning is the most critical one. Why? Because a mistake you find here on paper costs practically nothing to fix. But a mistake found after the app is out in the wild, that can cost a fortune. This phase is the battle plan, and absolutely everything that comes after depends on it.
And this whole complex planning process, it really just boils down to answering three simple questions. The plan has to define exactly what features are going to be tested, how they're going to be tested, what tools and methods they'll use, and of course, when it's all going to happen. You got to have those timelines.
So, once that high-level plan is locked in, the team starts to get really granular. They move into what's called test case design. And that recipe analogy? It's perfect for this. If planning was creating the menu for a big dinner party, this phase is about writing the detailed, step-by-step recipe for every single dish, making sure anyone can follow it perfectly.
And this is a perfect example of what I mean. The scenario is just the big idea. Let's test the login. But the test cases, those are the super specific, repeatable actions. What happens with a good password? Check. What about a bad one? Check. And what if the user just leaves everything blank and hits enter? Each one of these is a precise recipe to be followed to the letter.
So who's actually in the kitchen writing all these recipes? Well, as you can see, it's mostly the test engineers. They're doing about 70% of the work here. They're the ones digging into the requirements and writing out all those detailed steps. The test lead is there to guide the ship, review the work, and maybe tackle the really complex stuff. But it's the engineers who are doing the heavy lifting at this stage.
All right, the blueprints are done, the recipes are all written. Now for the fun part. We're moving from planning to action. This is where the hunt for bugs really and truly begins.
This right here is the moment of truth. The test execution phase is where the software, fresh from the developers, is put through its paces using those exact test cases we just talked about. This is where that meticulous, carefully crafted plan finally smacks into the reality of the code.
So what are they actually looking for? They're looking for defects, or as we all call them, bugs. Now, a bug isn't just someone's opinion that something feels weird. In testing, it has a very specific definition. It's any time the software's actual result does not match the expected result that was written down in the test case. It's basically a failure to follow the recipe.
So the process is incredibly systematic. Testers go through each test case one by one, and they meticulously document the outcome. Did it pass? Did it fail? Or was it blocked for some reason? They create super detailed logs, and whenever a test fails, they write up a precise defect report and shoot it right back to the developers to get it fixed.
And would you look at the shift in responsibility here?
During execution, it is almost entirely on the test engineers. We're talking 90% of the workload. They are the frontline soldiers, running the tests, finding those bugs, and documenting all the evidence. The test lead is still there, of course, monitoring progress and clearing roadblocks, but the engineers are the ones deep in the trenches.
So, after rounds and rounds of execution and fixing bugs, the process starts to wind down. But it doesn't just stop. It moves into the final and maybe most critical phase, making that go, no-go decision on whether this piece of software is actually ready for the world.
Yeah, it's really important to get this. Testing doesn't just fizzle out when you run out of things to click. The whole cycle concludes with a deliberate, formal event called test closure. It's all about looking back, evaluating the entire testing effort, and making a conscious, data-driven decision that we are done here.
Now, before they can actually close up shop, the team has to answer some pretty tough questions. Have we run everything we said we were going to run? Have all the show-stopping, critical bugs been completely squashed? And this one is key. Are the handful of tiny, cosmetic bugs that are still left, are they acceptable? Because let's be real, no software is ever perfect. And finally, all of this analysis gets wrapped up into a final test summary report.
And this last piece is all about accountability. Based on that final report, management gives a formal sign-off. This is a documented approval that basically says, yep, we've reviewed the evidence, we accept the remaining risks, and we approve this thing for release. It totally protects the team and it validates that the proper process was followed from start to finish.
Which, brings us to a final, really fascinating question. This whole STLC thing is this massive effort to ensure quality. But in a world where our apps are updated weekly, sometimes even daily, is the idea of a completely perfect, 100% bug-free piece of software even realistic? Or is the real goal just finding a smart, calculated balance of quality, speed, and risk? Definitely something to think about.